Hey, we're alive. Happy day. I need a better intro. If you have an idea for a better intro, let me know. We got a new problem today. What am I doing? I still don't quite know how to use IntelliJ. Like, how do you do a new file? I kind of wanted to copy a file. Control N. No. File new. There's no shortcut for new file. Is that true? That can't be true. Control Alt Insert. All right. Control Alt Insert. Okay. And the name of the problem is valid perfect square. So there we go. I already learned something new. It's 9 in the morning. So now I don't have to learn anything else new the rest of the day. Well, off to a good start. Highly productive. Control Alt Insert. Control Alt Insert. All right, got it. So what we're doing today is taking a positive integer number and writing a function which returns true if it's a perfect square, meaning two numbers can, one number can be multiplied twice in order to return it. So for example, 4 times 4 is 16. There's no number that you can, no whole integer that you can multiply in order to get 14. How to solve this? One way would be to just start at 1 or maybe 2 and just keep multiplying until we got past our number. That kind of seems like a lot. Seems like we could kind of guess a little bit better than that. So like if we see the number 1024, we don't need to calculate 1, 2, 4, 8, or, well, those aren't perfect squares, but you know what I'm saying. Was it 1, 2, 9, 16, 25? It could take you a long time to get to 1,000. So that makes me think it's almost like a binary search type problem. So there's no number that can be, like, you could at least divide by 2. So I'm kind of getting that. So I could take 14, divide by 2, 7. 7 times 7 is 49, way bigger than this. So that would be one starting spot. So we could basically check that number divided by 2. So 7 times 7 is 49. That's too big. So now we could jump somewhere between 14 and 1. Or, not, sorry. Geez. 7 and 1. 3.5. Let's call it 3. Check that. 3 times 3 is 9. That's too small. Go to the right. Halfway between 3 and 7 is like 5. 5 times 5 is 25. Let's go back 1. 4 times 4 is 16. And so at that point we tried 3. And we got 9, which is too small. And we tried 4, which was 16, which is too big. So we know that there's no whole number in between there. So I think that sounds good. It's less work than trying everything. Seems like we could do better than just dividing by 2. As we know, you can't find the square of a number and any number past the square, but we can't use the square to figure that out. So yeah, I think dividing by 2 is probably good enough. This seems like another easy problem. This month has definitely been easier. RazTube mentioned this. May has definitely been a lot easier than April. Not that I'm complaining. So we'll do a standard BST. Start equals 1. Num divided by 2. And then I forget how we know when we're at the end. Let's see. And there's potentially an overflow here. So we have to be careful with how we figure out the middle of these two numbers. So I think we can do basically the difference between these two. So end minus start divided by 2 plus start. So let's say in the example we just gave, that would be 9 minus, or 7 minus 1, which is 6, divided by 2 is 3, divided by 1 is 4. Yeah, I was thinking about doing that here. That'll already be integer division, because I've got integers. So that's good. Yeah, I think that's good. Okay. So if current times current is, keep a new variable for product. All right, if product is equal to the number we're looking for, then we return true. Otherwise, if product is greater than our number, then we need to move left. We need a stop condition. So if our product is greater than the number, then that means we need to shrink the end. So end equals num, and we do have to subtract 1 here because we've already looked at num and we don't want to have an infinite loop. And do you need else there? Else. We don't need to check this because we already checked if it's equal. So now it'll be start equals our number plus 1, and that'll move us to the right. And the only other case I can think of is basically while start is not equal to end. And then we can return false. Is that it? So let's walk through it. So if we're looking for the value 16, we'll say start equals 1, end equals 8. 8 minus 1 is 7, divided by 2 is 3, plus 1 is 4. So 4 is our first value. 4 times what? Yeah. Between 1 and, yeah, okay. So 4 times 4, 16. So we return true. And that's done. That was an easy one. What about 15? Start equals 1, end equals 7. 7 minus 1 is 6, divided by 2, 3, plus 1 is 4. Yeah? That's fine. I'm fine with that. Current times, so 16. It's not equal. I've got the stop condition down here. Is 16 greater than our number? Yeah, it is. So now our end equals our number, which was 4 minus 1. So end is 3. Start is still 1. That's what we checked previously. Wait. Our product was greater, so we said our end becomes... Oh, end was 7. Ooh. Which made our current 4. Alright. So now we got 1 and 3. We whip back around here. We get 3 minus 1 is 2. It's our current. 2 times 2 is 4, which is far less. So now our start becomes our number plus 1. So start is 3, end is 3. Okay, and that makes our current equal 3 minus 3 is 0, divided by 2, 0, plus start is 3, current 3. Oh, it shouldn't have continued. So here it would have saw that they were not equal. So yeah, I mean, this looks good to me. It did the exact right thing. It checked 4, that was too big. So it went to 2, that was too small. It went to 3. And shouldn't it check the 3? I do need to, I shouldn't check this here. Because I haven't actually checked 3 yet. So I should whip back around. I figure out 3. It's 9. It's too small. So at what point do I need to buck out? I think here. If it's not equal and the start equals the end, then it's false. And that never matters. So we should always converge upon either true or false. All right, let's try some samples. Feeling pretty good about this. Raz tubes, whoop. Am I handling the number as 1 or 0? Definitely not 0. If I do 0, I'll probably have an infinite loop. Start is 1, end is 0. Yeah, that's bad. Is 1 a perfect square? I guess so. What would we get there? Start is 1, end equals 0. Yeah, both of those are bad. Is 0 a perfect square? Let's try it. What do they say? I would think yes. Oh, yeah. Let's see. Try that again. What's up, Abdul? Long time no see. Ah, dang it. I'm so tired of Streamlabs. Also, I'm actually just tired of not fixing problems that I know about. I'm kicking a can down the road too much. All right, let's do our thing. This window is so long, it's crazy. Look how long this window is. Whoa. All right, refreshed. There we go. The input range does not cover 0. Oh yeah, they probably tell us. Oh, they don't mention it. So you taught me this trick, Abdul. So, okay, false and false. So their algorithm at least does something with it. Oh, it's interesting though that 0 was false. Okay. So they expect true for 1. So I wonder if I could do just something in here like was end. What would happen here? 0 minus 1 negative. No, it's not going to work. I guess I could just check if it's 1. If num equals 1, and just return true. All right, do a couple tests. I don't know. Solution dot is perfect square. 0 should be false. Well, sounds like it's not part of the input, so I'm not going to check that. Yeah, given a positive number, and I guess 0 is not positive unless you're in JavaScript. Because JavaScript has positive 0, and make sure that's true. I think because of the number encoding they have, there's 0 and there's negative 0. 0 equal negative 0? Phew. Okay. Lucky for us. Let's see. Assert true. And there's our value. Okay, what else is true? 2 is not true. What else we got? 3 is false. 4 is true. Might as well do the numbers that they gave us. 14. Well, we'll do 16 first. And 14. False. So I try some really big number. I'll try some big odd number. Yeah, I guess that's one kind of easy thing to do is like if it's odd. No, odds can still be prime. Yeah, sorry. Give squares, that's fine. Why are you yelling at me? Alright, try some big number. That's probably not a perfect square. Which one? I expected value to be true because I made a mistake here. This should have been false. Red, green refactor. That's taken an awful long time. Probably because this guy. Does that mean I have an infinite loop or I have an inefficient algorithm? I think the algorithm's good. I probably just have it off by 1 error so it keeps checking the same things over and over again. Let's see here. It's a shortcut to just break wherever it is. But I didn't run it in debug mode, so let's try that. We'll just see how these things do first. Oh, look at that. I hit the problem even before I get to my big number. It eventually ran. Is that true? Run it in debug mode. Man, why is that so slow? I thought I did everything good. So here our current equals end 13 and start is 1. What? How did that happen? 13, 1. So it's 12 divided by 2 equals start. Okay. So I want step over. Okay, product equals 49, which should be way too big. Start is equal to end. Nope. Product 49 is greater than 14. So our end becomes 14. Wait, I thought, what? Our end is 12, is 13. So how did we end up with a number that was bigger? What the heck? Current should be equal to 7. Oh, oh my gosh. I added to the num. Whoa. My B. should be changing the value of the... So that was pretty funny. All right, let's see how we fare now. That's much more like it. So it's always adding to the current value or minus. So if the product was less than the sum, I would just always get bigger, 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 bigger. All right, awesome. Let's drop this in there. I didn't. There we go. Drop this in there. Okay, taking a while. All right, true. Taking a while. Wrong answer. What? That's a perfect square? Okay, so what happened here? Got the breakpoint set. Alright, so we got a big number here. 808201. Our start was 1, our end was 404100. Okay. That's good. The current equals... I can't read the yellow. So the current is 202050. I guess I could look at evaluate expression, actually figure out what the right answer is. 808. Oh, I hope it's on overflow. 808, 201. I mean, we're only in the 100,000s, so I would hope not. 899 is the result. So we should converge upon that value. So our product equals... Whoa! Overflow, you're right. Ugh, you're right, because of multiply. Well, dang. So I guess another way to say this, and maybe instead of checking the product, we should take the original number, divide by... What would that look like? So do we call that remainder? And if we take our original number, divide by our current, and then if remainder equals... If remainder times remainder, that seems like a weird way of doing it. Is equal to num. Well, I guess I still have the same problem. So I don't know if it's too big or too small. I could cast it to a 64-bit integer, but it seems like cheating. So how do I know if it's too big or too small? What's another way to tell if the value I attempted for my squaring is too big or too tall? Too big or too small? I guess if this number was 64-bit, it wouldn't be the end of the world. Still feels like cheating. Long. $64 yeah, that's quite big. I wonder if there's some number that I could try other than 2. Hmm. Jeez. I don't know. Do like too long. Wonder what math.pal does. Doubles. I don't want doubles. Why is it always gotta be doubles? And this should be a long. Seriously, I can't combine a long and an int. I guess that makes sense. I mean, another way to check this would be to see if this number is negative. If it's negative, we know we overflowed and we know that it's not a right answer. So I think I like that better than casting to long. So if the product is less than 0, then we know it's too big. So I kind of hate it, but if it's greater than our number or it's less than 0, then we shrink it. Expected this value to be false. Oh, and it was true. True is the right answer. Alright, so that protects us from overflows, and they did tell us, I mean, they're passing it in an integer, so I think that's valid. Alright. I need to do a better job of thinking about overflows. I always think it's not going to be an overflow. And sometimes it is. Okay, that took a while. Oh, come on. No way. Really? On 598? Last executed input. Wow, look at that. Huh. All right. So we start at I mean, that's still too big. That's good. Current -1. And that's going down. Fast forward a little bit. Now we're looking at 18. The product is 324. Our num was 598, so this is too small now. So we should go back up. Okay. Current is 27. Makes our product too big. So we should go smaller again. So we're heading down, getting close. So this is probably just the infinite loop. 484 is going to be too small, so we're going to go back to the right. So what's our range now? We got start at 23 and end is 26. So that's good. We've got a very small range here. Need better posture. 24. We're looking at 24, which is in between those two. Because I'm doing the floor. Is it right to do the floor here? So how do we detect this? So now our start is less than our end. And it just is greater than or equal to. There we go. Alright, hey, it looks like the stream might be back. Not sure what happened there. My internet went a little bad. I'll start the music up again. Alright, so just in case the stream crapped out, I had my my less than greater than backwards. No! How is this possible? This is like, I don't know. I have some brain damage around binary search, I guess. This is not the first time where I've gotten into these little like off by one errors. Just kept on going. This is an awfully big number. Square root. It's funny. Looks like there's something special about this number. I wasn't even trying to get leak code. This is funny, everyone's asking the same question. I was hoping just... I mean, what the heck? Let's try this. Math.square root of this number. Yeah, so it's even number 4646340. So what's the problem? So our end is a very large number. Start is 1, that's fine. Our start has gotten bigger. Wait, our start is not correct. That's way too high. That looks like an overflow. Alright, let's try this again. Alright, so we got this big number. We divide it by half. Okay. Now down here, we got our product. Did it overwrap it? Did it go over again? 48. That's a pretty big number. Oh, excuse me. Convert to hex. What does hex do for us? This is a valid integer. And we got 3. So we should have gotten smaller. We should have moved our... So, I mean, this is bigger. So it should have shrunk my end. But it didn't. What? My product is greater than my num. That's what? 3, 6, 9 digits. This has 10 digits. Oh, right, because... Oh, my internet's going bad again. Man. Turn off music again. Yeah, my product was smaller than my num. So did I overlap twice? Is that what happened here? I guess we're just gonna do this. There's gotta be a better way to do this. And it should give the right number. No, it still didn't. Oh, jeez, I keep doing that. Keep copying the test and not thinking about the result. This should be a perfect square. So is that what happened there? Did it wrap twice? That's a big number. Alright, I think this is the correct solution now. And I'm curious how other people dealt with numbers. Did they just go up to 64 bits, or did they have another way of dealing with that that kept it in int space? I guess I could get rid of this check now that I'm in long space, but I'll leave it. Alright, let's see how we did. Not great. Look at this one though, wow. Oh my gosh. So they they also converted to long. Wow, number less than number is greater than long. What's res? Oh, number too long. Result times result is greater than num. Which, why wouldn't it be? Number times number. Then we divide by half. Wow. So let's say we have the number 14 here. They would say 14 times 14, whatever that is. That's way too big. Then they take result plus... What? So it's 14 plus 14 divided by 2. So 21 divided by 2 makes that 10. So now we're trying... What? Result, which is 14 plus num divided by result. 14 plus 1. 15 divided by 2. So now we're checking to see if 15 times 15 is greater than num. It is. So now we take 15 plus 14 divided by 15, which is... What? 0 divided by 2 is 7. So then, while 7 times 7, 49, is greater than num. Yes. 7 plus 14 divided by 7 is 2. No, 7 plus... I don't know what's going on here. I don't understand this. Let's see here. That's some math trickery. Let's see what people have to say about it. What? It's locked. Even after I submit it. Ah. Curses. Let's see, we can go to discuss. So I just kept with the binary search. So basically, yeah, I tried to run a search, and I finally gave up and converted my my numbers that I was comparing for my product to longs. So that was my cheap solution. I was trying to figure out how to do it in int space, but in 32 bits, but I just couldn't. We ended up getting a really big problem that that overflowed when I multiplied half of it, but it overflowed to a positive number instead of negative, so my check here didn't catch it. So now I don't believe I need this check anymore. Not that it matters, it's just extra fluff here. Let's try it. Now I was just trying to figure out how other people got around the 32-bit, 64-bit Taylor series. And I did see some people did some weird stuff that I don't understand. This is similar to what I did. So yeah, it looks like everyone pretty much solved it the same way. But I'll show you what the best answer looked like in Kotlin. And I'll show you. It looks pretty funky, so I didn't understand what the best answer was. So wow, just getting rid of that one check or just getting lucky on the running bumped me up quite a bit. But yeah, this is the best running answer, which I do not understand. So let's say we're looking at the number 14. We set res equal to 14, 64-bit. 14 times 14 is really big, much bigger than our number. So then we come in here and we say 14 plus 14 divided by 14. So we're looking at 15 divided by 2 is 7. Come back around, 7 times 7 is 49. That's greater than our number. So here it's 7 plus number divided by 7, which is 2. So now we're looking at 9 divided by 2. Okay, 9 divided by 2 is smaller. So now we're looking at 4. Come back around. 4 times 4 is 16. It's still greater than the number. So come back. 4 plus 14 divided by 4. It's 3. We get 7 divided by 2 is 3. So it does keep getting smaller. 3 times 3 is less than our number. So I just don't understand how they got this formula. Like, I see that my example worked, but I don't know the mathematical property here, rule that they're using. Yeah, let me see. I forgot the name of the paste bin now. It was like C++ SH. There we go. Oh wow, this is beautiful. So you convert it to long. What does long space long mean? So you just start at 1, going up to n, and you multiply the numbers. If it's equal, then you're true. Otherwise, if it's greater, return false. Okay, yeah, so you just start out there, boom, and that's awesome. Yeah, and it's very fast. If you only check up to the square root of the number plus 1 potentially, so that's I mean, I guess depending on how you solve it or how you kind of phrase it, log solution. Very nice. A super long. Nice. I've never heard of super long. It's funny. Character. Yeah, look at that. Long. 64-bit. They have long ints. That's cool. So why is an int and a long int the same? Yeah, I thought about going unsigned integer, but then it would have made it harder to detect overflows. That's bad. That's funny. Long int. Alright, well, my dogs have just woken up, so I have got to go take them out before they eat me. So, alright, thanks for hanging out. I might be back on later, who knows? But yeah, so far these challenges have been easier. So if someone's looking for a more gentle introduction to LeetCode, then it looks like Maze Challenge is a good one. All right, so I'm getting out of here. Y'all have a good one.